Question 4. The number of visitors arriving at a public library per hour is modeled by a Poisson distribution with a mean of 18 visitors per hour. To increase attendance, the library manager Priya launches a community outreach campaign. She then records the number of visitors over a single 6-hour period. Priya decides to use a 5% level of significance in her test. A. State the null and alternative hypothesis for the test. This is a Poisson test. HO M equals 18 per hour, 6-hour period times 6 equals 108. H1 M greater than 108. Because we could use this to increase attendance, we know this is a right-tailed test. B. Find the probability that Priya will make a type 1 error in her test conclusion. Type 1 error means rejecting HO when HO is true. Also, we know type 1 error is dealing with the critical region, given that HO is true. So, under HO, X follows Poisson distribution with a mean of 108. Let's draw the diagram. This is a Poisson distribution from 0 to 9999. It's a right-tailed test. This is a K. This is a critical region. Alpha equals 0.05. So probability of X greater than or equal to K less than alpha. We want to graph the Poisson distribution. Y equals Poisson CDF. M is 108. X 9999. To check the probability less than alpha, X to 9999. Then enter. Menu, go to 7, create this table. Scroll down to get 0.05. When X equals 125, probability equals 0.0588. When X equals 126, probability equals 0.0488. Probability of X greater than or equal to 125 equals 0.0588. Probability of X greater than or equal to 126 equals 0.0488. So this K equals 126. And probability of type 1 error equals 0.0488. Let's go to C. Priya finds that 128 visitors came during the 6-hour period. State Priya's conclusion to the test. Justify your answer. 128 visitors. Let's use this diagram. 128 is here, in the critical region or rejection HO region. So reject HO. Since 128 greater than 126, reject HO. Enough evidence to suggest that the campaign helps to increase the attendance.